And this is being recorded. I think that just told you that. It's, yeah, the theme of the seminar today from the Cambridge Forum for the Construction Industry is Sustainable Retrofit. And as I'm sure everyone who's attending is aware, it's a highly relevant topic given the current climate emergency we're facing and the need to reduce both embodied carbon that we use during construction of new buildings and reduce the sort of increasing demand on renewable electricity production that's going on. So trying to reduce the amount of energy we use both in construction and in use, essentially through reusing existing buildings and fitting those sustainably. We've got two guest speakers today. One is Alan Budden of Eco Design Consultants, and one is Iona Foster of the studio. Welcome both of you. And they're going to talk us through two different presentations, Alan first and then Iona, about sustainable retrofit, essentially. There will be an opportunity at the end of both presentations for speakers to respond to any questions you have. So please, as you go along, feel free to drop those in either the Q&A or the chat, and make, think about those as we go along, so we can pick those up at the end. Alan, I think I'm going to hand over to you to start, if that's okay.
Okay.
IT works.
Yeah, I've just lost the share screen button. Okay, so I need to stop that and share screen. Okay. Okay. Is that all showing okay?
It's great. We can see that.
Fantastic. Well, hello everyone. Thank you for inviting me along to this. My name is Alan Budden. I'm an architect and a passive house designer. Also I'm one of the technical people for the Passive House Trust. So talk on various client bits and pieces for them as well. So today I really wanted to concentrate a little bit about the Passive House Retrofit standard EnerPHit and go through some of the key principles and stuff. I've got lots and lots of stuff to say, but very little time to say it. So I'm going to really rattle through these, if that's okay. So here we go. So just a quick bit more background on myself. So a couple of slides on there, some of our finished projects from new build passive houses to retrofits of various stages. So this one down the bottom corner here is actually a full passive house retrofit down in London. And then also we've got some other projects where we've included PV. So this one here is a Passive House Plus. So that's got 24 kilowatts of, 20 kilowatt peak of electricity. So the owners there haven't had to pay any bills until recently. And it's interesting that more recently they're starting to, because of the change in how much they're buying electricity in the evenings compared to what they're selling it for. So now that they are now starting to have to pay a little bit until they get their batteries installed. Okay, moving on. So very quickly, I don't know whether people have been through Passive House before and understand the key criteria for that. But for EnerPHit, the Passive House Retrofit standard, it's slightly reduced. So you can see down here, there's a reduced standard on a couple of things. So your air change rate is 1 rather than 0.6. So this is air changes rather than air permeability. And your heating demand is 25 rather than 15. But what I think I want to really emphasize here is that one of the key criteria behind the whole of the passive house stuff isn't necessarily just about reducing energy and carbon. A lot of it is actually related to comfort. So the requirements here, so you've got the air tightness, that's as much related to comfort and good air quality as it is to the energy. Both really important. But other requirements are the internal surface temperatures, so equals high surface temperatures of at least 17 degrees. Again, that's comfort, not necessarily energy. Some are overheating, ventilation, good air quality again, primary energy and renewable energy. That stuff is obviously energy related, but a lot of the other stuff is around comfort and health and well-being. Just to kind of look at some of the other bits. So we've got here some of the items of the very low heating demand and surface temperatures and stuff I just mentioned. So what that really does is that affects in terms of reducing condensation of mold, external pollutions, and removing internal pollutants as well as external, which means warm, comfortable buildings, good air quality, and you're comfortable in summer. The alternative to this is sort of cold homes, poor quality of air, discomfort and so forth, and other illnesses. So what I think is quite important, particularly when you look at the retrofit market, there's a bit of a tendency at the moment to maybe think about moving towards decarbonising the grid. We just spoke about it earlier between us, moving over to putting a heat pump in. Or you put the heat pump in, okay, yes, it might reduce your carbon emissions, but it's not going to do anything in terms of your health and well-being. It's not going to make you more comfortable. Probably isn't even going to make you, it's not going to save you any money because electricity is expensive compared to gas. So there's a load of things like that. So if you start thinking how deep we should go, which is a big question. So we often get it, well, passive house is really expensive. I'll just do a little bit here and there. But I really encourage people to do everything well. And you can go back and do more, but if you do some elements well, then you can get much further. So really just this sort of summary here. So if you were doing a shallow retrofit, so you are reducing your emissions, you're not doing the health benefits, you're not helping to reduce the peak demands for the grid, because the grid just won't be able to cope, to be honest, moving over to electricity. There's a whole slide on that I could show you another time. So if you do go for the deep retrofit, which is kind of what we're suggesting, then you are reducing the demand. So we can, as a country, continue on with the electricity we've got because you're just using less of it. We can make it more healthy and comfortable. We can make the heat pumps more effective and to work so that they're going to work at a much lower temperature, and you need a much smaller one. And so there's some really good things. So your energy bills will be less. So again, you can be more affordable. So there's a lot of benefits really for going for the deep rather than the shallow. So I'd really, really stress that. Just really, really quickly, passive house standard. This is for new build really. Building regulations about 85 kilowatts per square meter. And then kind of what we do to try and improve on that, extra insulation, a small amount, you can see it's going down. Efficient shape, really important. I'll talk a bit more about that in a minute. Triple glazing. Yeah, for passive house, that's a requirement for the comfort as much as anything else. Air tightness, a big jump there. So getting your air tightness down and stopping those drafts and that heat loss, really, really advantageous, and a big amount done with that. Efficient ventilation. So once you are airtight, obviously you want mechanical ventilation, heat recovery, and to be effective. Thermal bridges, again, with a refurbishment, really, really important to try and look at those. And by the time you've done all that, you're kind of down to 15 kilowatts. So it's not necessarily rocket science. It's just about doing lots of things well. Okay, so the other thing that I love about the passive house stuff is it works. It does what it says on the tin. This is some research done by Leeds Metropolitan University on looking at measured data against predicted. The blue being the predicted and the red being the measured. You can see a lot of these are vastly bigger. And that's similar research has been done by a number of universities, and it's all showing pretty much similar things, that basically what's been designed in your EPC is basically about 50% under on average, which is outrageous. I mean, we had the whole thing with Dieselgate. I think the whole Sapgate may be coming at some point. But what all the surveys have shown is the ones down at the very bottom, these are the passive house dwellings. Not only are they much less energy to start with, but they're much closer in terms of predicted and the energy. So it does kind of do what it says on the tin. And to me, I think that's a lot of that's down to the air tightness, and how air tightness isn't necessarily done that well in the UK at the moment. Just quickly looking about the phasing projects again, a lot of times we get people come to us who are looking to retrofit their own house and have a limited budget. So you kind of then need to think, okay, how am I going to do that on a small budget? You can do the shallow retrofit. Like I said, you may only put 50 mil of external wall insulation and a few other bits and pieces. But that's locked in. Once you've done your external render or whatever you're going to do for cladding, then you're not going to replace it again later. So we'd highly recommend going for the deeper retrofit and maybe doing it in phases. So you might do the external wall insulation, then the windows, then the floors or whatever. You need to be really careful. You're doing it well, and you're considering thermal risks and moisture risks and all sorts of other stuff. But so you need to be really careful. But doing it in phases is definitely a workable solution. And particularly, you can also link it into when you maintenance cycles. So if you have got some relatively good windows, don't replace them yet. Replace those kind of when they need to be replaced, but think about the details and how they work. for later. And overall, that should be cheaper than doing a shallower retrofit. And you can do a thing called EnerPHit, terrible name, but which is basically certifying your project at different stages during that phased retrofit. So what we'd really recommend would be producing a whole house plan. So you can do the calculations, work out where you need to get to, then work it into phases, and so forth. So this is one we looked at for a big block down in London. Very quickly, I was going to go through some of the key principles with a few examples here and there. So to me, efficient shape is one of the big things. So this is some work we did for the NHBC Foundation. So this is a great book if anybody wants to download it for free, or occasionally you can get printed copies on the challenge of shape and form that we help produce, which is basically showing the difference. And in that, we produced the two extremes. So you've got a bungalow, which we opened up to look to see where the heat loss area is, and that's got 279 meters squared of heat loss area. We did the same thing for a mid-floor flat, which is the best in terms of form factor, 74 meters squared. We did that through SAP, and basically the mid-floor apartment, 2,000 kilowatt hours a year to heat. The bungalow, 4,500. Both identical in terms of construction, both beat current building regulations. So in reality, add 50% onto that as well. So you can see that the differences are huge, and that's purely to do with the amount of heat loss area. So the less heat loss, the better. Example of that for a new build. In fact, this is one of the pictures, the London house on the front page. By moving the front door from a little recessed lobby area on the outside to the front of the building, that saves 12% of the heat loss, which is staggering, really. That's a full passive house, so it is towards the extreme. But you can see just by reducing the surface areas can make a huge difference. So that's always the first go-to. We look at a refurb. So if there's anything to simplify the shape a little bit without changing it too vastly, then that can be a good win. And it's often saves money as well. So it's a win-win. Second one, insulation. Everyone knows about that. So a good duvet on your building, thick jumper, all those things. But do make sure you're using the right insulation and you've got the right stuff. So do make sure your U values and the lambda values are right. Internal wall insulation. This is some of the work that we do with the passive house planning package, and we've pimped it a bit to be able to produce lots of graphs. So we basically take elements one by one and see what can be done. So here we're looking at a number of different insulation types, going from wood fiber through to Kingspan. And as you can see, as you increase the thickness, the performance of the building gets better. So going down from the 240 kilowatts starting down to the 190. So lots of things there. And you can notice also that it gets worse after a certain thickness. That's because the floor area is getting smaller. Do the same thing with external wall insulation. So again, on this building, some quite good benefits from doing that. The roof insulation, very similar type of approach, and the floor. So sometimes with the floor, we might be looking at a refurb, and if it's a concrete floor, we might just be looking at using, say, 50 millimeters of PIR. So take the screed up, 50 mm PIR, and the board on top. So some quite okay savings in that one. It's not necessarily the best. Thermal bridging, again, really important, particularly on the existing buildings, because you've got all sorts of areas where you might be losing heat. To me, it's a bit like the old sleeping bag with a metal zip. It might be nice and warm, but that metal zip sure wakes you up. So yeah, do something with that. I've got a quick example here of a thermal bridge, which I think is quite staggering. If you take an existing building, if you're doing external wall insulation, your window was back here, and you look at where the heat loss is going, it's bypassing around the window straight to the outside. So your external insulation here, if it's not wrapped onto the frame, it's just going to bypass it. And I did some calculations from that, and actually it's the equivalent of not insulating 6.3 meters squared around the window, which is massive. I mean, it's almost like why bother doing that bit? It's just staggering how much losses from that little bit there. If you move the window out, so you move it out into the insulation, so the thermal bypass is greatly reduced. There's still a little bit of losses around that, but it's vastly smaller. So it's only 0.34, so hugely different. So it's really, really important to think about those thermal bridges around the buildings. Same thing if you're doing external wall insulation below ground. So if you're not insulating below the DPC, you've got the same issue. I think I remember seeing a slide before. It's about 800 millimeters up is the equivalent of not doing that below DPC. It's just like going out without socks on in the winter. Why do it? But it seems to be done all the time, to be honest. So it really is important to look at that. Also, by doing those things, also you're reducing the risk of condensation and mold, because obviously if you did it like this bit of wall in here is going to be really, really cold. So that's likely to be where your damp and mold and everything else is going to appear, because it's cold. It's why typically that's where you have stuff like that happening. Air tightness, really important. So this slide shows you, this is kind of a typical new build house. Air tightness 10, a 3-bedroom. It's a window about that big, size of an ATM is kind of what those drafts are put together. So if you can reduce it down, it can make big differences. This is a slide looking at passive house, to be honest. So at 0.6 air changes, the heating demand might be down to 16 kilowatts. If you then change that from 0.6 to 10, kind of the backstop of building regulations and what a lot of houses are, that goes up to 45. I mean, you can see how significant a change that can make. So often that can be the case. A lot of it's interesting in terms of air tightness that we're finding that some of the older buildings, so kind of the solid wall Victorian terraces, are actually maybe slightly more airtight than some of the newer houses, which are only sort of 10, 15 years old, which is shocking, really. But anyway, we can talk about it later. So yeah, in terms of draft proofing and making airtight, it's all about making sure you use breathable materials, vapor open materials, ones with little holes in, like a Gore-Tex coat. So it's about it breathing, not about putting polythene in, because you start putting polythenes in, you're going to get all sorts of condensation issues and all sorts of stuff. I'm sure a lot of any builders on this call will know now a lot of issues with mold and condensation on construction sites as we're getting tighter buildings. Need to really ventilate really well. So here's a MVHR. People know about that. I won't go into it today. So again, really important part. Windows. Just a very quick thing to say there in terms of why passive house is triple glazed. It's mainly because the building can, the people can feel differences between about 4 degrees difference. So if your surface temperature with a double glazing is, if it's -1 outside, it's going to be around about 16. Whereas with triple glazing, it's going to be 18. So you're not going to feel that difference. And air isn't going to move, which is the main thing. As air starts moving, and that's why you kind of feel the draft from it. Another really quick thing with windows, try and reduce down the frame as much as you can. Reduces some of the losses around it, and it's cheaper. Keep cool in summer. So yeah, we do need to really look at shading and make sure that's all works, and don't overglaze. So do look at that. And like I said before, passive house is great. It's got really good methodology. The PHPP is open source, really, because it's big Excel spreadsheet, so you can see how it works. And you can do lots of interesting things. So you can see kind of the reports we do here, taking each element in turn and then combining it together into different stages. So maybe the ACB standard, the EnerPHit standard, and so forth, and seeing what can be done. So yeah, I mean, this house here in Cooton, 53% savings just through air tightness and MVHR. So some big savings on that house. We've got down to pretty much EnerPHit standards. Yeah, do certify, mainly because it's a really good quality assurance to make sure everything you do is right. And there's various passive house certified designers, materials, and all sorts of stuff. So it seems to work, to be honest, which is the great thing. I think that's me about rattled through, I think. So hopefully lots of questions.
Thanks, Alan. That was really good. I really like this sort of really clear graphics that and diagrams showing, quantifying things like shape and form and thermal bridge and air tightness. They're really useful. Really great presentation. Thank you.
No problem.
We'll come to questions at the end. And now I'm going to hand over to Iona, hopefully, who should be able to open her presentation and kick off for us.
How's that?
Yeah, thank you. Yeah, that's good.
Whoops. Great. Thank you very much, Alan. Actually, give me lots of thoughts to respond to there as I go through. I'm talking particularly about the retrofit of historic buildings and the challenges with conservation group, but there are lots of overlaps with Passive House and decisions made along the way, so it'd be good to pick up some of those. I'm going to refer just to two projects. One that we, sorry, should I get rid of this bar? No, is that better? Two projects. One in Cambridge that was completed over 5 years ago for Trinity College, New Court, very prestigious Grade 1 listed building designed by William Wilkins in the early 19th century. And the second is in Oxford. This one's currently in progress, much smaller project, about £1 million worth. The New Court one is about 20 million, to give you an idea of magnitude. Trinity College, right in the middle of Cambridge, largest college, very prestigious location, New Court, which is adjacent to the Wren Library. So there was a lot of interest from the conservation group, particularly on the external appearance as well as the interior fit out. Importantly, New Court was the Fellows car park. So when it came to ground source heat pumps, that was very sensitive in that area. Designed by William Wilkins. Interestingly, the Gothic version was preferred to the more classical Palladian. And the refurbishment extended to the exterior of the building as well as the interior, and changes to the accommodation. So there was the opportunity to upgrade with the new glazing and the fit out. In Oxford now, Eleanor Court in Lady Margaret Hall, very different context. In the Victorian suburbs on the sort of northern side, right alongside the river, very leafy, green, and very pleasant setting. Less prestigious building, Grade 2 listed. It was a ladies' college, and it was started in the 19th century. This is a building which is very light, airy, double-loaded corridors, was thought to be particularly suited to women. The college is now takes men, so I think they've moved on a bit from that. But just essentially student rooms, but there had been quite a lot of changes, and it's much more intensively used now. So not so much sensitivity about the interior fit up, which was very useful for us, made it very simple to do the fit out. This is the original drawings. You can see the corridor. In fact, the only thing that seemed to be particularly sensitive about it was the language, which is a sort of English classicism, but with a kind of French Baroque Gallic touch, with some Baroque arches and the sort of relationship with the garden, and a really nice, interesting contrast of the red brick and the stone rustication and piers, none of which we had to change. So now why retrofit? Well, we've already been talking about this, but just to remind everyone, but that to achieve the 2050 target, we do have to significantly reduce carbon emissions on our existing buildings, because those existing buildings that we currently have will be 70% of building stock in 2050. And it can be done. This is architects at ACAN group say the same sort of things. It's a little bit more extreme now, and there's a real imperative that we all understand. So two very different projects, in fact, because New Court for Trinity College was a really extensive change in the rooms and the configuration and the introduction of bathrooms, offices, and the client asked for the energy use to be reduced in line with global targets. This was in 2009, which I think is quite remarkable, really. It's a very forward-thinking brief, which extended not only to insulating and reducing the demand, but as I said, ground source heat pumps in the courtyard and photovoltaics across the whole fabric. Photovoltaics, air tightness, of course, with the windows, heat recovery, mechanical ventilation, and the ground source heat pumps, which fed a new underfloor heating system. As with the Oxford project, we were able to use the chimneys and as vertical distribution, which is really important, and actually is a sort of one of those useful things about working with old buildings, that they do have really useful distribution routes. So here you can see this is a sort of 3 steps to get there for the Cambridge project. And you can see that step 1, which is the reduction in demand due to insulation, double glazing, is really, really significant and gets you 60% there. But on by other measures, and then the renewable energy sources in terms with the photovoltaics and ground source heat pump. Now in Oxford, we had a very sort of different lead into this project, and I think it's quite interesting to see how these projects, or what the genesis is at the moment. And this will change, but this one started with a sort of site-wide energy master plan, which was the college commission. Max Fordham's services engineers looked at this and initially identified which buildings had the very high inefficient energy demands, and you can see Eleanor Court there, which is a building we started with, was one of the highest. Interestingly, they also looked at the possibility of a site-wide heat pump system, even using the river for heat exchange. So the college decided to apply for the government funding called the Salix Fund, which I think has been around for just over a year now. They decided to focus on Eleanor Lodge as a sort of flagship startup project. So what the criteria for success with the Salix Fund is that you have to show that you can achieve the 500 for £500 or less per tonne of carbon saved. I won't go through the calculations, but we came in under that and made the application. I think it's interesting to see how that stacks up. Here are some diagrams not that dissimilar from Alan's. You can see on the left, 3 bars are showing the existing losses, how that's, and the energy demands. And then the blue bar was something which they used to corroborate by looking at the utilities and the bills across the college. Interesting that Max Fordham's did these calculations and they used the passive house planning package. Alan's nodding. Yes. Anyway, that seems to work very well. So and of course the same point here, that the losses, you can see the blue on the top is the external wall, the light blue, the yellow is the windows, and the green, surprise, surprise, is the air tightness. So quite quickly with new windows, you've got a sort of double win situation because you can start working on the air tightness. And you can see in the graph in the middle, it's the glazing and the MVHR and heat recovery. So those two go in parallel, and with a wall insulation, we're getting down to sort of 60% saving. Now the red bar, the red dotted line is our way of sort of showing the graphics. If you then put in heat recovery, you're not needing to supply so much energy, so you're reducing that demand as well. This is another way of saying the same thing: cumulative effect, windows, MVHR, then the wall insulation, wall linings. That gets you down to sort of more than 60%, around about the 70% mark. Eleanor Lodge, very much simpler project, as I say, to do with lining the walls internally and reglazing. That's the green bar. Mechanical, the heat recovery, we're able to use the existing extract in the ensuite toilets, so no changes to the internal fabric there. And then the blue is the air supply, and we were planning to use the chimneys. So 2 options for the windows, and we haven't decided which one to go with. It's very interesting. So it's a sort of 2-horse race here. The first one we thought of obviously was secondary glazing, but I think by anyone's standard, secondary glazing is a fairly crude solution, and I'm interested, in response to Alan's comments about deep retrofit, whether this is the right solution for historic buildings. It does have the advantage, technically, that it keeps the thermal line all in one nice, neat vertical line. But the other option for this project is to reglaze, and we can reglaze with double glazing, and we can use the same frames because there are now these products called sort of vacuum glass, which are 2 panes of glass with a tiny vacuum, and they do give you very good U values. We also have to line the windows as well, but there are some advantages to that, and here's the 2-horse race. We've looked at operational carbon, which is more or less the same for both options, but what is different is the embodied carbon. So in the second option with, the first option, with a secondary glazing anyway, there is quite an add-on for the embodied energy of the aluminium frames. Whereas the first option, which looks more complicated, but is simply reglazing these existing timber windows. I think, where are we for time? Yes, I wanted to talk about the process for managing the risk and the approvals for heritage buildings, because the retrofit has sort of 2 strands to it. There's the appearance and the character and significance that's the subject of a lot of thought in the conservation area, and how we manage that. And then the more invisible aspects, which are to do with humidity levels. So we manage both of them actually with tests and prototypes and mock-ups, but the visual prototypes, room mock-ups for the character and the visual appearance, which we then review with the conservation team, with the client, to get some consensus. The fabric, which initially we might know nothing about, we just know that it's a very old building. We review the research relevant, analyze the existing fabric, thermal imaging, material properties, take samples particularly, and then put those into the WUFI modelling, which will give us the understanding of how that building is performing thermally in relation to humidity. And that allows us to make the decision about how we can change that thermal properties, lining it basically. So risk to character and significance, these are this is the way we do a mock-up room. This is one of the very simple rooms in Eleanor Lodge. The same wood fiberboard insulation I think was in one of Alan's proposals. What we had to be careful of is how we finish that to make sure that that it's vapor permeable. And interestingly, when we had previously used this product on New Court, they had a really nice, helpful product. I think it was called Pavatex, which had an integral finish. Now we found that the product that replaced that, called Pavadry, was actually no longer vapor permeable. So unfortunately, this company had got distracted, perhaps we should say, from producing the right product for this sort of project. So we were able to explore a couple of options. One was using Thermocell, which is vapor permeable. Here's the secondary glazing fitted in. So in this room, we did one window secondary glazing and one reglazing the existing timber window. Here's the secondary glazing, bit unsatisfactory with the sight lines, lovely views, and the poor student is really no longer able to use their their windowsill, and probably tempted to open the secondary glazing, which is a problem. And at this point, you're interfacing with the way the room is used. Some rather bad pictures here of the Finio reglazing, which is very exciting, but I can't show you it installed at this point. Not many buildings, as far as I know, have been retrofitted with this type of glazing. New Court, the testings and mock-ups were very extensive because the interiors were sensitive and they had to be changed quite a lot. The relining and the way that interfaced with the way the students were using the rooms, and I think the important sort of interface with existing details, all of which was scrutinized quite heavily, I understand. Peb's nodding because she had direct experience. And a mock-up here of a room with the furniture, showing the rather nice sort of dialogue between the new modern plywood materials and the heritage white plaster and so on. And I think what was really clever and really strong about this project is that it invented its own narrative to explain and to make distinct the relationship between the new and the old, and how that would support the way the rooms are used for study and for learning. So a really nice sort of clear storyline there. Nearly every room was different, so really extensive study of the significance of the interiors to deliver the heritage impact assessment. Now compare this with Eleanor Lodge. This isn't the final document, but it's a very simple statement of how the windows and the linings work. Nearly all the windows are the same. In fact, nearly all the rooms are the same. So extremely useful, but nevertheless very, very effective. So finally, have I got 5 minutes? 2 minutes. Just wanted to talk a little bit about the physics, actually, which is the invisible risk here, the risk to the fabric. So that's the bit in the yellow circle on the right there. We review the research, and some of the process here is to look at the research, to look at what's been done. The really tricky thing is managing the risk of mold. First up, you have to understand the existing building, what's there. In the case of New Court, a lot of on-site surveys, measurements, monitoring, thermal imaging, looking at air tightness went on. But I think perhaps that that all culminates in a examination of the structure. So taking a core hole and looking at what's there. Interestingly, at Eleanor Lodge, we did the very same thing. A simple core hole. Both these buildings are masonry construction, very, very thick walls, and no cavity. And so what happens is that the masonry acts like a sponge and it dries out on the inside. So the humidity flux is from the outside to the inside. And this is why it's so important that the breathability on the inside is maintained. Once you've got this data, you can set up the WUFI models, which show you how the humidity changes with temperature and gives you that dynamic of how, indeed, how that can change over the year. You can see on a sort of baseline sort of representation, the blue straight line on the left-hand side. This is representing an insulation of phenolic insulation, which would not be vapor permeable. So that would be completely unacceptable. Whereas the sort of fuzzy yellow line on the right is showing one of these. Pavadentra actually is the product that was used in the Cambridge project. In Oxford, really helpfully, this enabled us to make some really important decisions. So you can see here the PIR sort of traditional type insulation, again, is simply not acceptable. Pavadry is this product which we were considering use somewhere in the middle, but too high a risk. So we're working with a product called Isolair, which is the wood fibre insulation, and we are very mindful of keeping that vapor permeable on whatever product we find in. So some simple physics, we have to sort of dig into what is going on in these buildings. It can be done. Keys to success on this type of project, like most, having the right client team, really important to do the testing, mock-ups, models and samples, and to collaborate with the conservation team, which is the council, as well as your client. Thank you.
Thank you, Iona. That was great. Really interesting presentation. Even for someone who'd been involved in one of the
yes, exactly. Knows more about it than I do.
It's great to hear about. And I think I've got a couple of questions, and well done for everyone keeping to time. We've got a couple of questions from Simon. Let's just have a look in the chat, which are both quite interesting. So we'll start with those. And he said, backed up by the numbers, our speakers are suggesting fabric first to retrofit, whereas, oh, sorry, this has popped up. Whereas UK government drive, i.e. homeowner grants for 5K, is about heat pumps essentially. There's lots of heat pump first companies out there pushing this forward. So, and very little going on in terms of fabric first, you know, other than, I suppose, the Insulate UK process going on. But what could we do to sort of tackle this this issue of funding being mainly for heat pumps as opposed to fabric first approach? Have you got any ideas, I suppose, to both of you?
Shall I jump in first on that one?
Yeah, go for it.
Yeah, there is kind of a bit of a nod to the government's just announced in terms of zero VAT on some of the insulation products. But that's kind of been reduced from 5%, which isn't necessarily that well known, and it's very difficult to actually get.
Okay.
All of these things. So there is a little bit of a help there that you can get. If you can separate out the insulation measures from the rest of it, it has to be separate, and it can be associated measures as well. So if you are doing external wall insulation, it can cover the render and other bits and pieces as well.
That's really useful to know, actually.
But it is very difficult. It's VAT. And so as VAT is always difficult to try and claim back anyway, so it is not so straightforward. To me, I think it's all about lending money. I think what I'd encourage, if any government people are listening, is to try and find a way of people accessing money at a very low interest rate, not like the Green Deal at sort of 20%, to carry out these measures and then pay back from the savings they make longer term. I think that's what a lot of other countries are doing. I'd be interested to see whether any of the pension companies are starting to look at this as well with green investments. I know that they've started to look at renewables, often the case, to be honest, now, where you can have your green pension can be put into those, but whether they can be used to help insulate other people's houses. I mean, it'd be a fantastic way of doing it if there's any finance people out there.
Yeah, all good ideas.
But just need to get on with it, to be honest. In some ways, also, on the other hand, I feel sometimes with the government grants and stuff, people keep thinking, well, we'll wait for the government grant rather than getting on with it. And then when it does come, it's usually not as good as people hope it would be. And other issues, but that'd be my take. But
yeah, it's very difficult, isn't it? Because the problem with private residential homes is the disruption, internal changes to the linings and the fabric. Double glazing less, but the disruption to people's homes. Whereas, you know, adding on a heat pump is an easy option. That's innovation. It's not a solution, I'm afraid. And so far, I mean, the sort of work that we've been positively engaged with is work for institutions where there are huge economies of scale and repetition. So yes, it is a problem area, and a lot more needs to be done.
That was interesting, Alan. This is a question I had for you actually, was about the phase retrofit and whether in your experience there was any order that was good to do it in, say on your own house or a small property like that. Yeah. You know, what's the best thing to do first and why? As
you can probably see, I am halfway through the retrofit. To be honest, I quite like leaving this here rather than getting plastered, because it's quite a bit of a talking point with some of the air tightness tape you can plaster onto here. There isn't really. I think a lot of it goes to what needs doing and what the desires are. So sometimes, to be honest, some of our clients, it is about the extension because they just need that bit of space. So it's about doing that bit well and thinking about how it's going to join in. Often it is windows, but again, you need to think that the big tip again, I would say, is bring your ventilation forward. Don't necessarily leave that to the end, because there's all sorts of risks in terms of your condensation risks. My house, I was doing some initiative from roof panels on the roof, and they were hugely delayed. So I ended up the winter just with an air tightness membrane as the waterproof single layer. And so I was getting condensation forming on the inside of that membrane and having to mop it down at times because it was just getting, and using a dehumidifier. So getting that ventilation in early is really, really useful, particularly if you're going to start to get tight, and you can kind of, the ventilation will deal with some of that humidity and then try and reduce that down to where I was saying that the sweet spot between sort of 40 and 60% humidity. But really, it does depend on the project.
Thank you. There's another question in the chat for you from Peter Durant asking basically what were the main issues to overcome in terms of the historic context, and in particular I was thinking about the windows and this discussion about double glazing versus secondary glazing. And I know when I worked in New Court that Heritage and Historic England were very into the idea of secondary glazing and very against the idea of renewing with a double glazed unit. Did you find the same thing in Oxford, or was it a different approach there? Well, moved on.
Yes, I mean, when people say, "Oh, you can't double glaze, it's a heritage building," that's what everyone says, and it's a myth. It's not true, and actually, the imperative now is stronger than ever, and they cannot simply refuse it, because single glazing is no longer acceptable. So in Oxford, it's actually a much more modest project, and I think having completed this project in Cambridge, we are showing everyone how successful it is. It's really useful to have that as an example. And we do have a particularly understanding heritage officer in Oxford, and I think it'll be interesting. I'm meeting her tomorrow, and we'll be able to talk about this secondary glazing. Is that a good solution? I don't know. You know, we're just starting a huge refurbishment of the historic fabric in this city, in Oxford, and we want to get quality, high standards for the right cost, and you know, with the right energy savings. So it'd be very interesting. But no, I think the resistance is dwindling away.
I think it's also interesting what you changed in terms of the window sizes. I think you went from smaller panes to larger panes, which again has some quite big changes.
Not necessarily. I mean, now there's something. I mean, what we are doing is we're putting large panes of glass, and we're probably going to have to put fake on them. But as you've probably observed, that in itself avoids quite a lot of thermal bridging.
It does. So, it's interesting. I can't remember which college it is, but there's a college in Cambridge that's just getting passive house approval, and the conservation officers there have approved to go from smaller panes to larger ones. Which is again quite significant change in terms of the heritage, which is
absolutely
interesting. That there is starting to be a bit more of an understanding, and I think so. Very well done.
Absolutely.
Peter's dropped a bit of a follow-up question in there about heat loss through the existing frames and core bridges there, and whether whether we have analysed that in terms of the two different ways of doing it. Have we done any work on that?
That's on the reglazing of the timber frames. Yeah,
as opposed to say a secondary glazing system.
Yes, no, we haven't is the answer to that. You know, there is some cold bridging across a timber frame. I don't know, Alan. Do you know how significant that is?
Timber's not so bad, so it's not as bad as some of the aluminiums and stuff. But what's usually quite interesting as well with the heritage ones, often you might have a box sash or something, so you've got quite a deep frame that's hidden away, so you can hide that and the insulation over it, so you can insulate around it much more and keep the nice thin lines of the traditional window, but with a big frame. So the box sashes we're finding as quite a good way of insulating the buildings, and we've done some mock sashes, so you have kind of, these are in conservation areas more than listed, where we have got a nice triple glazed unit that pretty much looks identical to what was there before, except it's nice because you can hide it away into the recess behind the brickwork and insulate a little bit in front of it to get those side values down, which is very encouraging. I think.
Sounds really good. I mean, I know on New Court, because it was grade 1 listed, there were a lot of conversations about loss of fabric. So actually, you know, you couldn't take any part of the window away. And it became a very sort of deep conversation about the difference between conserving something for future use and preserving it as it is, and where it can't be used as well. So I think Peter was actually referring to that as well. I think, you know, that's the idea that you had to keep that existing sash, you know, you couldn't replace something that was different, was quite fundamental in the story to that particular conservation officers that were involved with that. So it's, there's different levels of stuff you can do, I think.
And preserve it from rotting and then being destroyed.
Exactly.
The physics right is really important.
And Peter's concluded with, I suppose there will always be some compromises. It's all about how we value them. Fantastic topic. So well done, everyone. Was there another question? I think we've got a few minutes left.
I mean, I think, you know, just that point on the windows, that it's immensely satisfying to upcycle an old window to current standards, to be able to use that timber fabric and not just ignore it, but to bring it into a contemporary. And, you know, here's a college, Lady Margaret Hall, who are very proud of what they're doing. And if it is visible or different in some way, that's going to be a good thing.
It is, definitely. There's a couple of questions in the Q&A I hadn't noticed. There's one from Bob Ench. Is there any data available on the improvement in the performance of the two buildings you retrofitted after the works were finished compared to before?
Yes. Well, one of them hasn't even started yet. So, I mean, but the project in Cambridge, yes, there is data, and it's performing even better than envisaged, actually. You know, I think it's above 80% savings on the bills. It's not quite passive, but
no,
it's really good.
And part of obtaining the consent for those works in Cambridge were to continually monitor, which is quite interesting as well. So there was such an idea that somehow the works that were being carried out would be a risk to the building itself, and be continuously monitored over the years following the consent. So it doesn't necessarily provide energy and data statistics, but it provides information that tells us that the fabric isn't rotting or decaying or falling away. It's quite interesting as well.
I mean, and the project in Oxford, we got the government funding and achieved the levels, but on top of that, we've also added in air source heat pumps, which are going to power the existing radiators. Very, very economic system. We not even putting underfloor heating in. So we will be well up there in terms of energy savings. You know, really good example. And so simply done in this case, so easily done. Start to finish, start for funding confirmation to end of project on site handover is going to be less than 6 months.
Wow, that's amazing. Almost unbelievable.
Can be done.
Well done.
And I suppose doing a mock-up was part of that, producing something that said this is what it's going to look like, meant people could take quick decisions based on that.
Yeah, the mock-up is really important. I mean, we have to make a fast decision, and I think it does a number of things. We got a contractor in and we can talk about the sequencing and how quickly they can do it, whether they have 2 teams on site, you know, whether they can work while they're doing the windows. So that was really helpful. We get the conservation team in to look at the windows and the mock-up so they get confident, they're confident about it. And importantly, the college can look at it and see, yep, this is what we're getting, this is what and we can make this decision about what type of windows. So that was really useful to be able to progress that, given that everything is happening so quickly.
Great. I think we've got another question in the Q&A from Adrian, and he's asked about MVHR first and then EWI, and I think, Alan, you've already kind of answered that in a way, haven't you? Put your ventilation in so you don't have condensation risk when you haven't done the rest of the works, you know, or get your ventilation into, you know, avoid that sort of risk of condensation. Is that right?
Yeah, definitely.
And there's one last one from Adrian, which will be our last question because we've got about 2 minutes left. On heritage windows with brick or stone mullions, how can you improve insulation? And I would say it depends on what the detail is, I think. But I don't know, Iona, if you've had any experience with that.
Stone mullions.
Yeah, it's a tricky one. It's about getting your window in line with where you can put insulation on the internal face of the stone, isn't it? Essentially, it's kind of building.
I have seen one project tackle this actually. What they did with that was they used diathanite, so the cork lime plaster, onto the inside of the stone, and they basically formed some shutterworks and formed a new one. So it's only adding, I think, 20 millimeters or something of insulation, but that's enough to reduce.
That's enough.
Huge,
that's enough. So, surprisingly, so and the appearance then on the inside is to look like stone. Yeah,
exactly. So that's one way we've seen it done.
Yeah, there are enough products around now to deal with almost any eventuality. But yeah, that's an interesting one.
Great. Wow.
Just one quick thought I'm finding really interesting is doing various different types of projects. We're finding that the older Victorian terraces are ones and Edwardian stuff. We can go further in terms because their form factor is better because it was less material, so cheaper to build and all the rest of it. It's the 80s and 90s houses that are the difficult ones. It seems bonkers, really. But
that's the 20% that's going to have to go.
Yes.
We'll keep the old ones. Right. That's why we have to get used to doing the old ones. We'll keep the old ones, but the ones that are going to go, I'm afraid, are the 70s, 80s buildings.
Yeah. I'm just doing one of those at the moment, and it's hard work. Expensive. But and also the older ones are usually in a better, more sustainable location, so you can walk to the pub and you can walk to work and all the rest of it as well. So it's a win-win.
No, it's really useful. Thank you very, very much. I found both your presentations very interesting. Great Q&A as well. And I hope everyone got their questions answered. And thank you very much again.
Oh, sorry, one quick thing. If any architects out there looking for work, we're recruiting. Shameless plug. If you want to do some passive house work.
I'll be in touch. No, I'm kidding. Thanks a lot. Thank you very much, everyone, and goodbye.
Goodbye.
Bye.